in pulses of light that travel around the world, carrying our phone calls, business conferences, and important internet data. But now hold on a second. How exactly do you send light over great distances and still manage to extract information from it? I mean, fiber optic cables have to carry light for literally thousands of miles, like across oceans. Yet, if you've ever shined a flashlight down a long hallway, you'll know that over any more than a short distance, the light scatters and eventually becomes too dim to make out. Well, that is where optical fibers come in. Those really skinny tubes that make your Christmas tree look nice without having to string up any messy lights have some special characteristics that allow them to work over incredible distances. The main way that fiber optics behave differently than your flashlight is that they take advantage of a physical phenomenon called total internal reflection. You see, a fiber optic system doesn't just shine light down any random hollow tube. Instead, optical cables are made up of a core of glass or plastic surrounded by an outer layer called cladding. Both the glass and the cladding have an inherent property called a refractive index, which is basically a measure of how fast light can travel through something. For the system to work properly, the cladding needs to have a slightly lower index of refraction than the core. Now, sometimes this is achieved by using pure glass, that is silicon dioxide, for the core, and then doping the cladding with chemicals to lower its refractive index, while other times the core itself can be doped to raise the same value. Either way, this difference means that if light hits the cladding at a shallow enough angle, it will be completely reflected at the same angle instead of passing through the cladding. That means that it can continue on down the fiber in a zigzag pattern indefinitely. Well, not quite. Although in theory, the optical signal should just keep going all the way until it reaches the other end of the fiber, the pesky real world always has a way of throwing a wrench in the pudding. No matter how high-end and pure an optical cable is, there will always be some imperfections, even if they're so small that you could only see them at the molecular level. And these will cause some of that light to scatter, weakening the signal over distance until eventually it can't be understood by the equipment at the other end. So to combat this, long-distance fiber runs are assisted by repeaters or amplifiers. A repeater gets placed at a point down the fiber where the signal will have weakened significantly, but it's still strong enough to be read. Once the light hits the repeater, it's turned into the corresponding electronic signal, which is then turned back into light, much as it was at the origination point, and then sent along on its merry way. Repeaters come with a latency and a complexity cost, though, so many modern long-distance systems now use amplifiers instead. These gadgets have optical fibers which are doped with chemicals that directly amplify light when the weakened signal hits them. So, the ions in the fibers themselves will re-emit the same signal, but much more strongly than what came in, and it continues down the cable. In this way, optical fiber runs can be designed to be really long, making them a more viable choice for long-distance communication than copper. Optical fiber is not only more cost-effective than copper wiring, it's more power-efficient, and it even goes farther without requiring a boost. Also, because it's thinner and doesn't cause electromagnetic interference to the cables around it, it's common to bundle a bunch of optical fibers, each of which can carry multiple wavelengths of light, into one large cable, making it possible to transmit enormous amounts of data without taking up too much space. This versatility means that fiber optics have found uses outside of just communication, such as in endoscopy, where their flexibility allows a user to light up and view inside very hard-to-reach spaces. This is useful in fields like engineering, plumbing, and even medicine.